So are you all done with that 6.3 exercise?
Yes, sir.
Okay. So we had started with 6.4, right? So where are you people right now? Like, what are you working on, all of you? Tell me one by one.
Sir,
Second
at
sub,
our
sir.
school,
Next one.
One thing, put it in the
yes,
chat. What question or exercise you have completed? Just put it in the chat.
sir, in our school or what we have done.
Know what you have completed in the tuition note, or all the questions up to which you are totally comfortable. You know everything thoroughly. You have practiced well. Okay, first of all, confirm all of you. 6.4. Second question, Nitya. 6.4, first question. So first question, 6.4, okay. Just give me one confirmation, all of you. I need confirmation, yes or no. Have you completed up to 6.3 exercise? Who all have completed up to 6.3? Just give,
Yes, sir.
put it in the chat window, all of you.
Yes, sir. Till 6.3 completed, sir.
Good evening, sir.
Good evening. So next Monday on 12th, I'll check your notebooks, okay? I'll check your notebooks for all the exercise up to 6.4 next Monday, coming Monday on 12th. Is that okay with everyone?
Yes, sir. Yes, sir.
Up to 6.4 should be completed. We will be completing this within the next 1 or 2 days. And after that, there'll be one more exercise remaining. So that we will see whether you are able to complete or not. That's fine. But at least up to 6.4, it should be complete. Make sure all of you do that. Okay. Fine. So since in the class we had done up to first question only, let's move on. Let's start with the second question here. Some of you who have already completed this, it's all right. Either you can wait for me for a couple of minutes, or you can start working on the third problem. If you are totally comfortable with this, you are sure about the second question, you can move on. You can try the third one. Otherwise, if you need to see how I solve it, you can wait with me. Okay, fine. So confirm all of you can see the screen also.
Yes, sir.
Okay. Diagonals of a trapezium ABCD with AB parallel DC intersect each other at a point O. Okay, first of all, let's draw the trapezium. ABCD is a trapezium where AB is parallel to DC, as you can see here. All right, they're saying that the diagonals intersect at a point O. So let's draw the diagonal also. This DB and AC, and they intersect at the point O. All right, if AB is equal to 2CD, so what things are given here? AB is parallel to DC. This is given. Then they're saying AB is equal to 2CD. Find the ratio of the areas of triangle AOB and COD. Okay, anyone has any idea what we can do here?
Construct, sir.
So we should prove they are similar.
Okay, which triangles?
AOB and COD.
Absolutely. So we'll take in triangle AOB and triangle COD. Tell me, how do I prove that this is similar?
AA similarity.
Okay,
A, sir.
which angles are similar? Tell me.
Sir, first angle DOC equal to angle AOB is a vertically opposite angle.
Okay,
Then angle
is equal to angle BOA vertically. Everyone agrees with this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then this angle
the
and
D is a transversal.
Alternate.
Alternating mirror.
yes. So I can say take any one of the angles. So let's say I take this BAO, and that will be equal to what? BAO will be equal to
OCD.
Was
BAO will be equal to angle DCO. Right. So we can say by AA similarity triangle AOB is similar to, remember A will be corresponding to C. That's why I'm writing AOB corresponding to COD, not DOC. Okay, A corresponds to C because this angle A was equal to this angle C here. All right. Now what do we do? What was the question? Basically what they were asking, find the area, find the ratio of the areas of triangle AOB and COD. So basically they are asking us to find the ratio area of triangle AOB by area of triangle COD. It will be equal to what? Square of the corresponding sides, right? So I can take this side AB and this side,
by
yeah, AB by DC whole square. And we already know what is AB by DC. AB it is given as equal to 2 CD. So 2 you can write it however you like. You can convert that to a ratio, or I'm just writing like this. You know how to fix this up, right? Everyone understands this? So this will be 2 square, that is
4.
4. So since it is a ratio they are asking, since they are asking ratio, so we should write it as 4:1. So this is 4 by 1. So the ratio is 4:1. Here also you should be careful. It should be 4:1 only, not 1:4, because they have asked us to find the ratio of AOB is to COD. AOB is written first, then it is COD. So you should be careful. You should only find triangle area of triangle AOB by area of triangle COD, not the other way around. Okay. So it has to be 4 by 1, which you will write it as 4:1. So this has to be written in the final conclusion, 4:1. Confirm, guys, all of you are okay with this?
Yes, sir.
This was a very straightforward problem. We took those two triangles, AOB and COD, and by AA similarity, we proved that they are similar. And once these two triangles are similar, this theorem just now we have learned in the previous class, right? Area of the corresponding area of the triangles will be square of the area of the corresponding sides. And this AB and DC was already given. So some of you may want to convert this also. If you want, you can write it as AB by CD is equal to 2 and then directly use this ratio there. Okay, you can do that also if you want. Okay, so I think that is a simple calculation. You should be able to do it on your own. Can I move on to the next one? Confirm, guys.
Yes, sir.
Yes, sir.
All right, let's see the third one. In this figure, 6.44, ABC and DBC are two triangles on the same base BC. We're talking about ABC and DBC. There are two triangles on the same base BC. Okay. If AD intersects BC at O, show that area of triangle ABC by DBC is AO by DO. Okay, so how can we do this? Tell me, anyone? Try to do this on your own first.
Sir, so can we take AC is parallel to BD?
AC is parallel to BD. Can we take, that's what you're asking?
Yes, sir. Because it's not given, that's why.
Okay, there is nothing in the question that suggests that AC is parallel to BD. They have not given that it's a trapezium or anything, no? So we can't take that. Think what we can do. What else can we do here? No idea, anyone?
If we prove that ABC and DBC are similar, we can prove that AO by DO.
I was not able to hear you. Say that loudly a little bit. Tell me again what you're saying.
If we prove the triangle ABC and DBC are similar, then we can find AO by DO. We can show that, sir.
ABC and DBC, if we prove that they are similar, still how will AO and DO be part of this? They will not.
Sir, you said
Uh-huh.
if the sides are similar, then the lines are the medians, then altitudes, they will also be in the ratio, no, sir.
But remember here that nobody said that AO is a median or altitude, nothing. They're just intersecting in between at O somewhere. Does the question anywhere suggest that it is the median or the altitude? No, right?
No, sir.
Or do you have any way to prove that it is the median or altitude? Is there anything suggested in the question which would tell you that
No,
it's a
sir.
median? It's not, okay? It's not a median or altitude. So what we can do in this question, don't think too much. Just drop perpendicular from this A to this point. Let's call this as P, and you can drop another perpendicular from this D, and let's call it as Q. Okay, think that it is a straight line, of course. So understand that these two are perpendicular. Now what will happen to the area of triangle ABC by DBC? Now I have drawn the altitudes. Tell me, what should be area of triangle ABC and DBC? What are the names here? A, B, D, C. A, C, they intersect at O. Let me call this as P and Q. Now, based on this figure, tell me what is the area of triangle ABC by area of triangle BDC. What can I write? Don't think complicated, think simple. Half into base into height we can do, no? We have the height over here.
Half into BC into AC.
Yes, half into BC into AP. This will become the area of this triangle. Why? Because BC is the base and AP is the height. Half into base into height. Same way, we can do this for this guy also. BC is the base and this guy will become the height. Even the figure is not perfect, but imagine that it is a perpendicular line. That will be the altitude, right? So BC will become the base. So here also half into BC into, what will be this time?
DQ.
DQ. And as you can see, half and half get cancelled. BC and BC also get cancelled. So from that we can write area of triangle ABC by area of triangle BDC is equal to AP by DQ. Now somehow I need to prove that this AP by DQ is equal to AO by DO. Is it possible to do that? Can we prove that AP by DQ is equal to AO by DO? Is it possible or not?
So can we do
Proving
like
that
the
triangle
side
AAP is similar to triangle.
or the angle opposite to, I mean the sides opposite to equal angles are equal?
Say that again. Sides opposite to what?
Here the sides opposite to the equal angles are equal. So
That is within the same triangle. Within the same triangle only, if you have two angles, then the sides opposite to equal angles will be equal. So suppose this is 50 degree here, and if this one is also 50, then these two opposite angles will be equal. But if you have these angles in two different triangles, then it will not be same, right? Because if that was the case, then all hypotenuse will always be equal, because every angle which is opposite to 90 degree will become equal. So is that true? Every side, is it equal? All the hypotenuse are equal. This guy is equal to this one. No, right? You understand?
Yes, sir.
Okay, so we can't say that sides opposite to equal angles, not from two different triangles, within the same triangle only. Okay, but just understand AP by DQ I have, and I am interested in AO by DO. I need to prove that this AP by DQ is equal to AO by DO. Should be very simple, no? Prove that APO triangle is similar to DQO. Then all its corresponding sides will become equal. AP by DQ will become equal to AO by DO automatically by CPST. So let's do that. In triangle APO and DQO, what all do we have? We have angle APO is equal to angle DQO 90 degree. That is by construction. Okay, of course you will write that construction part over here. Okay.
Angle AOB is equal to angle angle POA is equal to angle QOD.
Yes, absolutely right. Angle POA is equal to QOD. Why are they equal?
Vertically.
Yes, vertically opposite. So we'll say by AA similarity, triangle APO is similar to triangle BQO, and because of that, by CPST, we can say that AP by DQ is equal to what? AO by DO. Okay, wait, I have written this BQO, but it should be DQO, right? The triangle should be DQO, not BQO. That was a mistake. By mistake, I wrote here, I wrote B, but it should be D, right? DQO, not BQO. That is why you will have AO by DO. AP by DQ will be AO by DO. Now, my first equation said this area is equal to AP by DQ, but AP by DQ is equal to what? AO by DO. So from 1 and 2, I can say that area of triangle, what was that? ABC,
Yes, sir.
ABC and BDC. Is equal to AO by. Tell me, everyone understands this? What we did here? we had done a small construction. We dropped this AP and DQ perpendiculars. So because of that, what happened? We were able to simplify the ratio of these two areas using the simple half into base into height formula. So this became AP by DQ. Now our job was simply to find out that this AP by DQ is equal to AO by DO. So that can be done easily by proving that these two triangles, APO and DQO, these two triangles, they are similar. So if they are similar, then by CPST, we will be able to prove that AP by DQ is equal to AO by DO. So that is how we did this. All of you confirm you're okay with this?
Yes, sir.
Yes, sir.
Okay. Now don't make me solve all the questions. See if you can solve the fourth one on your own. So this may seem a little different, but try to write down whatever is given in this, draw the figure and write down whatever is mentioned and see if you can do this on your own, prove it on your own. So this is the condition. If the two areas are same, area of ABC is equal to area of PQR, you can understand that their ratio will become equal to 1, right? Can everyone understand this, what I have written here?
Yes, sir.
They said that two triangles are similar and their areas is also same. They are similar and areas are same. So if areas are same, I can write the ratio to be equal to 1. But by the theorem, we know that area of the ratio of two similar triangles will be equal to square of the corresponding sides. And that will become equal to 1. So from this, can anyone tell me how we can prove that these two triangles are congruent?
By SSS congruence.
Yes, one by one, we can take all of this equal to 1. So we will be able to prove that AB is equal to PQ, BC is equal to QR, and AC is equal to PR. Tanushree, you are joining now?
No, sir. Actually, I changed my account and I joined, sir. I have a network issue.
Okay, fine. So since we have written for one of them, we'll just do similarly and we will write the remaining things because all of them are similar. Similarly, BC will be equal to QR and AC will be equal to PR. Okay. What did we do? Everyone understood this? Confirm?
Yes, sir.
Yes, sir.
You guys confirm and everyone is okay with that problem? I heard only from just one person. Was that Kavya? Rest of you, have you understood?
Yes, sir.
Yes, sir.
Understood, sir.
All right. Charan, Midula, Tanushri, I didn't hear from you.
Sir, understood.
Yes, sir.
Okay, Deep, are you there? Deep is not here. Okay. Fine. So let's move on to the next one. Please do this on your own, guys. EF are respectively the midpoints of AB, BC, and CA of triangle ABC. So these three are midpoints, all right. Find the ratio of the areas of DEF and ABC. Yes, this I want you people to do this. Use a little bit of logic and see how you will do this. D, E, and F are respectively the midpoints of AB, BC, and CA. So let's say this is ABC, midpoint of AB is D, F. And you are supposed to find what? We need to prove here or find here, find the ratio of the areas. TEF by areas. So try to do this on your own. Do you people remember the midpoint theorem?
Yes, sir.
When we join the midpoints of two sides, it is parallel to the third side.
Third side.
Yes. So use that over here.
It is also half of it here.
So if you have trouble writing it down, how to write it, that we will do it. I will do it for you. Just tell me what is the idea. Anyone knows how to do this?
Sir, now DF is parallel to BC, sir, and also DF is half of BC, sir. In same way, other two sides, similarly, other two sides are also like that only we should do, sir.
Mhm. Okay, very good. So we can use the midpoint theorem and we can write it like so let's take one of them at a time. So one pair at a time. So D and F are midpoints of AB and BC. Using midpoint theorem, what we can say? DF is parallel to BC and also DF is half of BC. Is that right or not?
Yes, sir.
So what you do is write it as a ratio DF by BC. So DF by BC is equal to what? 1 by 2. Let's write it as 1. Similarly, we can show that, or just write one more step, just say that so this DE is parallel to AC and that is half of AC also. So same way I can write, no need to write all of them again. So this FE is half of AB. So from 1, 2, and 3, what we can say? What all do we have? Tell me. DF by BC is equal to DE by AC is equal to FE by AB. And that is equal to 1 by 2. All of these are equal to 1 by 2. So by SSS similarity, can I not say that triangle DEF is similar to triangle ABC? all the corresponding sides are in equal ratios, right? All the ratios are equal to 1 by 2. Okay, but the naming is not correct. I have written DEF is corresponding to ABC. That is not right. Just let's correct that mistake. Try to think, guys, what will be the corresponding sides. I'm saying AB corresponds to FE.
FED, sir. Triangle FED.
Sir, DF corresponds to BC.
So AB is FE, and now let's do BC. BC corresponds to
D.
F. So we can from this we can see on LHS B and B is common here, F and F is common, so we can understand that B from this corresponds to F from this one. Okay, same way, let's take one more side and then it will be more clear. FE, okay, AB we did with FE, BC we did with DF, then AC we have to do. So AC corresponds to DE, right? AC corresponds to DE. So as you can see, C and C and D, that means C corresponds to E. So this C and this D, and of course, then it will be A will correspond to E. So if I write A, B, C, it should be E, F, D. A, B, C corresponds to E, F, D. Did you people understand what I did here? Getting the correct correspondence. What vertex is corresponding to which one? So if I want to write similarity condition, it will be by SSS similarity triangle ABC is similar to ABC will be EFD. Now, if that is the case, what do we know? Area of triangle EFD by area of triangle ABC should be equal to what? Square of the area of square of the corresponding sides, right? So we can take any one of them. So let's say I take FD or DF, whatever, by BC whole square. And we know DF by BC is equal to what? 1 by 2, right? Or DF by BC we have already written as 1 by 2 here. So let's use 1 itself. No need to call. This is fourth equation. Tell me, guys, do you understand this? E, E, and F, they were given the midpoints. Okay. So what did we do? We used the midpoint theorem. We said that if DF is parallel to BC, I mean to say if D and F are the midpoints, then it will be DF will be parallel to BC, but this is not needed. We are more interested in this idea. DF is half of BC. So DF by BC is 1 by 2. Same way DE by AC is also 1 by 2. And FE by AB, this is also 1 by 2. Since all the three sides are in the ratio of 1 by 2, So this basically gives us the SSS condition, right, for similarity. All the three sides are in corresponding ratios, same equal ratios. They are in proportion. And we can prove that they are similar, and once they are similar, their area ratio of the areas will be square of the ratio of corresponding sides. So it will be 1/4. Tell me, guys, are you all okay with this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so you will practice all these sums on your own. Okay, just because I solved it does not mean you know how to solve it. Make sure everyone, you can go through the PDF which I send and go through the recording if needed, and then solve it on your own. All of you practice it. Okay, so there are 2 more questions remaining here, and some tick the correct answer and justify 8 and 9 also. So see if you can finish this on your own. The remaining last 4 questions. Try this in your home. Of course, after you practice all this. Yeah, after practicing up to 5th question, then move on to these 2 and see how much you can do. So let's stop here. Anyone has any questions for me? Any doubts in maths? If anyone has any doubts in maths, you have to ask me now. All right, then let's stop here.